All right, answers to review for quiz 14. And you had to use some of your log rules in here to get some of your answers to match. So I apologize for not giving you a heads up on that. But hopefully, if you watch this video, you'll remember some of the log rules and see how they got some of the answers. All right, so number one, denominator is going to be your u. Derivative is 2x. There's no 2 in the problem, so I'm going to divide by 1/2. So 1/2, and then make sure you change the limits. So plug in 2. 2 squared is 4. 4 plus 1 gives me 5. 3. 3 squared is 9. 9 plus 1 gives me 10. And I have 1 over u. So if I integrate 1 over u, I get the natural log of u. And then I plug in 10 and 5. So I get the natural log of 10 minus the natural log of 5. So sometimes this answer right here is good enough, but if you notice, it does not match. And if you remember, whenever you subtract two logs together, that's the same thing as combining the logs into one log and dividing the two. So 10 divided by 5 gives me this. And obviously 10 divided by 5 gives me the 2. And then I have something that matches. So more than likely you got it here on your own. Hopefully you remembered the rule about subtracting the logs to combine them, and then you'd be able to get the answer. But some of you may have got hung up right here. All right, next one, u is going to be 2x. Derivative is 2dx. There's no 2 in here, so I need a 1/2 out front. So it's the integral of tangent u du. If I integrate tangent u, tangent u is the negative natural log, absolute value cosine u plus c. Plug your u back in and move the negative to the front, and we get our answer right there. Number 3, I've told you or emphasized that anytime you see a natural log in an integral, it's got to be your u. Derivative of the natural log is 1 over x, so that takes care of the x on the bottom. So that means I have the integral of sine of u du left. Integrate sine, we get cosine. Since I ended up with cosine, I need a negative. And plus c, plug my u back in, negative cosine natural log of x plus c. On this one, you could have changed this to cotangent if you wanted, and then just integrate cotangent. I just went ahead and left it and made u my denominator, which is sine. Derivative of sine is cosine. Cosine is present here, so that means we have 1 over u. It's a definite integral, so I need to change my limits. Plug in pi over 4. Sine of pi over 4 is square root of 2 over 2. Plug in pi over 2. Sine of pi over 2 is 1. Integrate 1 over u gives me the natural log of u, and then we need to plug in 1 and square root of 2. So natural log of 1 minus the natural log of the square root of 2 over 2. Natural log of 1 we should know is 0. Again, since I have a negative here, I can move that negative up to give me an exponent, and that makes me flip this. When I flip this and clean it up, we end up with a natural log of 2. So that's why natural log of 2 is our solution. On number 5, we have a polynomial on top of a monomial. And I've said many times, anytime that happens, you need to break it up. So x over x squared gives me 1 over x. And then I have 4 over x squared, which is what I have here. So 1 over x integrates into the natural log of the absolute value of x. This, you can move it, make it 4x to the negative 2. When I integrate that, it's going to give me 4x and then a negative, so that's why the negative went away. We had a negative cancel out, so we have 4 over x. Plug in 2, so I get natural log of 2 plus 4 over 2 minus, plug in 1, so I have the natural log of 1 plus 4 over 1. Natural log of 2 stays. 4 divided by 2 is 2. Natural log of 1 is 0. This gives me 4. Distribute the negative, gives me a negative 4. So natural log of 2, 2 minus 4 gives me minus 2. So natural log of 2 minus 2, B is our answer. 6, we've got an e. We've only got one e, so that means its exponent has to be the square root of x. Derivative of the square root of x is 1 over 2 square root of x. I do not have a 2 in the denominator, so that means I need a 2 out front. So 2 times the integral of e to the u du. If I integrate e to the u, I get e to the u. Plus c, put my u back in, 2e to the square root of x plus c. My answer is 6. 7, find the average value on the interval of from 0 to 1/2. So I need 1 over b minus a, so 1 over 1/2 minus 0, which is what I get here. That reduces to 2 because that gives me a 1/2 on bottom. 1 divided by 1/2 is 2. I've got my integral from 0 to 1/2, and then I've got my function inside. If I integrate e to the 2x, we should be able to do that in our head without using u and get 1/2 e to the 2x. Integrate 1, I get x, and then we need to plug in 1/2 and 0. So if I plug in 1/2, 2 times 1/2 gives me 1. So I just have 1/2 times e, and then 1/2 plug in for x just gives me 1/2, and then minus plug in the 0. So that gives me e to the 0, 1/2 e to the 0, and then plus 0. So I have 1/2 e plus 1/2 minus e to the 0 is 1, so that makes this 1/2. Distribute the negative gives me a half, and obviously the 0 goes away. My 1/2s cancel right here, and then 2 times 1/2 gives me just 1e, and that's why 1e is our answer. Number 8, again, we've got a polynomial on top of a monomial, so we need to split it up. E to the x squared divided by e to the x squared is the same thing as e to the 0, because we have x squared minus x squared, which gives me 0. E to the 0 is the same thing as 1. I'm going to go ahead and split it up here. 2x divided by e to the x squared is the same thing as 2x times e to the negative x squared. So on this one right here, I've got 1e, so that means my u needs to be the exponent, which is negative x squared. The derivative of that is a negative 2x dx. I've got the 2x. I don't have the negative, so a negative combined with a negative there is going to give me a positive. So if I integrate e to the u, I get e to the u, and then I need to plug my u back in, which gives me e to the negative x squared there. So x plus e to the negative x squared plus c. So that's how we get c as our answer. 9, remember we treat the base of 7 just like we would an e. So that means my exponent is my u. Use the chain rule for the derivative. So that's 2 times x plus 1, and then it would be times 1, but I don't have to put it. I've got the x plus 1 in the problem. I don't have the 2, so that means I need a 1/2 out front. So the integral of 7 to the u du. So the 1/2 stays. I need 1 over the natural log of the base, which is 7, and then times 7 to the u. And don't forget your plus c. Plug your u back in. I multiplied these two, 1 over 2 natural log of 7 times 7 to the x plus 1 squared. Remember that we could move the 2 up here and make this a natural log of 49. So keep that in mind whenever you're trying to do a multiple choice. It may be the natural log of 49. All right, we're going to turn a definite integral into the limit of a Riemann sum. So we have cosine, and then we need to put something inside of cosine. So we start with the bottom, which is pi. So that's why I have pi plus. And then we need b minus a over n. So 2 pi minus pi gives me pi over n. I need to multiply that by I. And then I have b minus a over n on the outside. So b minus a is pi over n. Remember, this and this will always match. Doing the reverse on 11. So we've got our integral. I've got 2 plus right here, so that means 2 is going to be my lower limit. B minus a is 5, so that means I need 2 plus 5, and that gives me my 7. And this is inside of the natural log, so that means my function is the natural log of 8, or natural log of x dx. So we change this limit into this integral. All right, on 12, it was kind of tricky. I started out using 3x plus 12 as my u, which gave me 3 dx, which meant I had 1/3 out front, 1 over u, which gave me 1/3 natural log of the absolute value of u plus c. And then I put 3x plus 12 back in to my natural log. But if you notice, there's no 3x plus 12 over here. So then I was like, well, I see what they did. They took a 3 out of the bottom. So they took a 3 out of these two and made it a 1/3. So if I divide both of these by 3, that makes it x plus 4 down here. Okay. Then my u is going to be x plus 4. My du is just dx. So it's just 1 over u du. Integrate that. I get the natural log of u, and then plug my u back in. And my u was x plus 4. So we get 1/3 natural log of x plus 4. So that one was kind of tricky. This answer right here is technically correct, but obviously we didn't have the answer to match it. Okay. So that told me I had to go back and redo it. 13, just integrate both of these separately. If I integrate e to the x, I get e to the x. And e with no variable is the same thing as a number, so it's just like integrating a number. When I integrate a number, all I have to do is put the variable on it and then plus c. So e to the x plus e times x plus c is my answer. So that's how we got that. On 14, this is the one where the answer choices were incorrect. It looks like I copied up here and pasted here and then forgot to change my answer choices. But again, it's another average value problem, so I need 1 over b minus a, b minus a. So 6 minus 4 gives me 2, so that's why I have 1/2 out front. We're going from 4 to 6, so that's why we have 4 and 6 here, and we're integrating 1 over x. So there's 1 over x. If I integrate 1 over x, I get the natural log of x. I plug in 6, I plug in 4. This is okay, but as you saw earlier, they're probably going to want you to put the natural logs together. Since we're subtracting, we can combine those into one natural log and divide. So 6 divided by 4 is going to reduce to 3/2. Okay. They could also move this exponent to the top as well and make it the square root of 3/2. So keep that in mind. All right, 15, last one. So we got another one of these exponential problems with the base other than e. So that means u needs to be my exponent, which is x cubed. The derivative of x cubed is 3x squared. I've got the x squared. I don't have a 3, so that means I need to put 1/3 out front. So then we have 2 to the u du. I need to change my limits. So if I plug in 0, I get 0. If I plug in 1, I still get 1. So even though it doesn't look like it, I did try to change my limits, but my limits ended up being the same. So if I integrate 2 to the u, I have 1 over the natural log of the base and then times 2 to the u. I put this together out here, which is 1 over 3 times the natural log of 2. I plug in 1, which gives me 2 to the first. I plug in 0, which gives me 2 to the 0. 2 to the first is 2. 2 to the 0 is 1. 2 minus 1 gives me 1. So that's just 1 times this, which gives me 1 over 3 times the natural log of 2. Again, we could move the 3 up here to the exponent, and it could be the natural log of 8. So that could be a possible answer. All right, so there's your answers to review for quiz 14. Send me a message if you have any other questions. You can also meet me in the morning before school in the library. Just send me a message and let me know you're coming. That way I can expect you. We will see you guys tomorrow, and we will be taking quiz 14.